All right, so let's go through this worksheet real quick. 6.3, geometric. It's really binomial into geometric. So let's do this. Senior talent show scheduled to take place this afternoon. Michael is in the stats class, practices that bottle flipping. He tells his friends that the probability of success landing in water right side up is 20%. Assume that each water bottle flipped is independent. Okay, so there's a couple things. If he flips the bottle 10 times, how many do you expect land on the right side up? So here's the deal. We already know probability of success is 0.20. So we're going to use that idea and opportunity to do these runs. If he flips the bottle 10 times, how many do you expected value? N equals 10. Probability of success is 0.20. So let's do that. Expected value, also known as the mean, is 10 times 0.2. So we would end up with 2. I would end up with 2. And there's my justification, is actually just doing the expected value of a binomial Benz. This works out to be a Benz problem. What's probability he makes exactly 2 flips? Well, let's do that. Let's do probability that exactly 2 of the 10 end up happening here. Well, so we do know that by rule, 10 combo 2, probability of success, we want to see exactly 2 of them. That means we're going to see 8 failures. So exactly 2 of those flips that he's going to do that. Now, actually, in my calculator, I'm doing the binom PDF function. Binom PDF function. So I'm doing trials 10, probability of success 0.20, and I want to see exactly 2 flips. Enter, and I get 0.30. 30% chance. What's the probability that he makes less than 2? Less than 2. Okay, so that's like the probability that he makes 0 flips, or the probability that he makes 1 flip. So in my calculator, I could do a binom PDF of 0, a binom PDF of 1, and then I will add those together. Or let's do a binom CDF, right? So distribution, binom CDF, let's go 10. Probability of success is 0.2. X value is less than 2, so I'm going to just put a 1 in here because I want it to up to and including 1. So I'm doing a CDF of 1, and I end up with 0.376. If you don't know that, then think about, right, that being 0 and 1, add those together and you get that. But so then you can play with that. All right, what is the probability that he makes at most 2 flips? Probability that x is less than or equal to 2. That means at most. So we're going to do x is equal to 0 plus probability that x is equal to 1 plus the probability that x is equal to 2. So it could be at most. It can go all the way up to and including 2. So I'm going to go back to my binom CDF function again. I'm going to go 10.2. In my x value, now I'm going to change it to 2 because it can now equal 2 as well. That's going to be 0.678. And there you go, right there. The next piece, after the first 10 flips, Michael wants to do 10 more, but his teacher is getting annoyed with all the noise and tells him he must stop flipping once the bottle lands right side up. Once it lands, so that's what we call a success. Success. Find the probability that he lands it on the first try. Guess what we just talked about? This is now geometric. Why? Because we no longer, so the fixed trials used to be at 10, right? And it's not anymore. So now there's no fixed trial. So now we're looking for the first success. This is geometric. So find the probability that x equals 1. Well, we know the probability of success is 0.20. So boom, done. Find the probability that he fails on the first and lands on the second. Oh, so we're saying the probability that the first success is on the second. Well, it's going to be 0.80 on the first and 0.20 on the second. Multiply that together, that's 0.16. Right? So 0.2, I'm second guessing myself, but yeah, I'm right. Okay. Find the probability he fails on the first 2 and lands on the third. Well, that's the probability that x equals 3. And so that's 0.80, 2 failures. And finally a success. So 0.8 squared times 0.2. And we get 0.128. Find probability he fails on the first 3 and lands on the 4th. So probability that x is equal to 4. So that means we are going to fail the first 3, finally have a success on the 4th. So 0.8 to the third power times 0.2, and we got 0.1024. Okay, that's what that looks like right now. Yeah, and I could keep doing this over and over again. I'm actually going to skip this little thing right here. The number of flips it takes for bottom of the right side up. We can fill in the table. We already did 1, 2, 3, 4. I can keep this going for days, right? But I'm not. I'm just going to skip it for right now, just to kind of keep on pace with what we need to get done. Number 9, find the probability that lands on the 10th try. Write a generic rule for that probability. That kind of came from the notes if you want to go watch the other notes. So then we would say the probability that x is equal to any value that you want to put out there, k, is equal to failure. That's going to be k minus 1. And then finally, the last one is always going to be a success, since you're going to do it until success. How many flips do you expect? So that's what we're talking expected value. So they should have got this from the last notes. Expected value is also known as mean. It's 1 over the probability of success. So that's what it would be right there. Okay, so that's what that part is. Now let's check that next one. Let's just do one more real quick. Just do it. 30% of students chewing gum in the bag after Taco Tuesday lunch. You desperately need some gum. You randomly ask students in your class finding someone who has gum. G is the number of students you ask until you find gum. 30% chance. So P equals 0.30. Describe the probability distribution and check to make sure the conditions are right. So I'm thinking this is geometric. So I'm looking for bits. Is it binary? Yes, either people have gum or they don't. Is it independent? Yeah, each person, whether they have gum or not, doesn't affect the next person having gum or not. Are we doing trials until first success? You betcha, till I find that gum. And success rate is the same as 30% that in general have gum. So yes, that's going to work. What's probability that the third person you ask is the first person with gum? So probability that x equals 3, the first success comes on the third person. So that means we had 2 people that failed to have gum. Finally, the third person is 0.7 to the second power times 0.3. So there is about a 15% chance, right? 14.7% chance. What's the probability that you find your first piece of gum by the third person? So up to and including the third person. So x is less than or equal to the third person. So that's going to be the probability that it came on the first person, or probability that it came on the second person, or the probability that it came on the third person. So knowing that, I'm actually going to use a little function here in my calculator called geomet CDF. And I'm going to put 0.7 is the probability, 0.3 is the probability of success, and I want to see it on the third attempt. So let's give that a shot. Let's go geomet CDF. Let's go 0.3, and x value is 3. So it looks like I'm going to have a 0.657. So by the third person, by the time I get to the third person and ask them, that's the way I'm reading it, by the third person. So I get to the third person, and yep, it's about a 66% chance that I'm going to have to ask at most 3 people to get that gum. How many people do you expect? Expect is expected value. Expected value of x in this case is 1 over probability of success. So if we did 1 divided by 0.3, you end up with 3.33. So it would take about 3 people, maybe 4 people, to get your first success. That's what you would be expecting. Would you be surprised if you found your first piece of gum when you asked the last person in your class of 30 students? Probability that probability that x is greater than or equal to 30, right? So, right, that's what it's really asking. Or let's just, in the fact, since there's only 30 people in the class, let's just do probability that x is equal to exactly 30. So what does that mean? That means I had 29 failures, and finally I got to my last person, and they actually had the gum. So 0.7 to the 29th power times 0.3, and that is 0.000097. So almost no chance that it takes exactly 30 people to get that, right? That just doesn't seem right to do that. Find the standard deviation and distribution. Actually, you know what? We're going to skip that. Don't need you to do that. So that's what all I got for you right there. So a little bit of binomial to start this gig off right here. Switched over to geometric. and kept on with the geometric over here, right? So know the difference between binomial and geometric, use the right functions, get those right formulas. Now do some Khan Academies.